Hello and welcome back to Compiler Programming. In the last video, we left out with this state of FizzBuzz, which is nowhere near completion, but we are able to create an array on a stack and we are able to set some items in that array. However, there are a couple of problems. Problem number one, which is like the actual issue I ran into the previous video, was that I was missing semicolons. That was actually a problem, but for the next issue that we will run into if we try to move this inside of the loop, so try to set this code there, is that right now this is expected to be constant. So if we look at the source code of this, which is something like set array item, right? So this code here, I cleaned it up after yesterday's video, but nothing really fancy, just this helper function. But the point is, we need to statically know this index, right? We are extracting it from immediate because this is what we put into displacement to clarify, right? If you have an array of bytes like this, right? So 0, 1, 2, whatever, these are bytes. Our register is going to be pointing to here, to this element, and then this stuff is just kind of giving us offset. For example, if you want the third element, this is going to be like index. The byte size is 1 because we are dealing with array of bytes, I think. The question is actually, are we? Yeah, we are. So yeah, this requires the index to be known. And there is actually a way to represent index in such a way that this is still a single memory operand. And this is where SIB encoding comes into play. So let's actually refresh our memory. Sorry for change from dark to light. If you used to light dark setup of my videos, but unfortunately this website does not really have a dark theme and I don't want to mess with styles and so much. Anyway, so this is the addressing mode, and there is this SIB mode which we actually do use for stack pointers, because you have to, like, if you look into this mode, there is no SP register, so I can't be using modrm byte to encode displacement from the RSP. That's why we have to switch into SIB mode to actually do the RSP one. And RSP one is sort of this version where we we have this register, and then we use the illegal index to remove this. And to be precise, I think so this is the 32-bit displacement. We are using let me find the right option. I guess it is one of these, except that we set this index register to be invalid, and that forces this to be 0. So we end up with like the displacement plus register. However, for our arrays, we should actually be able to encode this in a nicer way. So if if the index is going to be in the register, and we can put it there, and then what's going to happen is we will have the base register, right? So getting back to this thing, we'll have a base register here, which is the array itself. And then we would have index inside a register. that we will use for this multiplication, and the n here is 1, 2, 4, or 8. In our case, we know that we can switch on, like we can assert that item byte size is one of those things and use the right scale. So this is what we are going to be trying to do. I never really made, I think, SIB work correctly before, so this is something new to me as well. But let's just dive in there. So we need to have it in as an operand, and I think we actually do have it as an operand. Yeah, there is this parent type SIB added at some point, but we never actually made it work. So there is this SIB scale, and there is operand SIB, and it's also here, right? This is just kind of a boilerplate, and this is a special operand where again we have to set the scale, we have to provide the index, we have to provide the base, and we can provide the displacement. So in reality, we don't even need to have displacement. It's going to be 0 in this case. So we could use this version, but I think this is something for encoding to decide which of these 3 should be used, because it can check what is the size of the displacement and choose the right encoding. So like that's fine. However, this is what we want to do. So let's try to make that happen. We're not gonna do this. I mean, we could have 2 versions, like one version for the like for immediate stuff, and the other one for non-immediate. Maybe that's what we should do. That's fine. Let's do it that way. So we say if operand is immediate of index value operand, then this is what we are doing. Like this is actually the most efficient way to do what we're trying to do. So that's it's good if we can make that happen. Okay, so let's keep it like that, right? So we're statically calculating the right displacement. It will result in the smallest encoding, and in general it's nicer. Whether this is the right place to be doing this optimization, that's debatable, but for now that's fine. Okay, now we need to deal with the other part. So this actually will be common. Item descriptor and item byte size, we will need to know them regardless. And there is going to be actually another fork of this. So here we say else if item byte size is 1 or item byte size is 2, 4, or 8, right? So this is what we need to check. So we have to unfortunately do this very long thing that doesn't fit into my recommended size of 100 characters. It's fine. Let's make it more vertical. Anyhow, if this is one of these, we can use SIB encoding, and otherwise I will assert and say not implemented. It's not that this is particularly hard, it's just I don't want to look at it today. So what are we going to do here? Well, basically we are going to do a very similar thing to this thing. We will say value star index value in register is ensure register. I think there is such a function. It is either here or it is inside of the function. So there is ensure register on memory. Is there just ensure register? Apparently not. Well, that's something we can very easily do. We say ensure register builder, and then we say if value operand type is not operand type. Is it just called register? I don't remember. Yeah, it's just called register, so that's fine. Okay, so a bit lost. It was here, yeah. If it's not a register, then we just put it in register. That's sort of the same thing. Yeah, they end up doing the same things, but they have slightly different semantics for checking the condition. So that's fine. We have ensure register, builder, and index value. And then here we would create that operand type SIB. Byte size is fine. And then we need to put a bunch of stuff into SIB. Operand SIB. So it's going to be what? Well, it is base is what was previously the register. Maybe I should rename it to base in the other one as well. And then, so this is sort of this part or this part here. And the rest is going to be index is index value index value in register reg or something. Then I take displacement from the original operand, same as here. And now index goes in here, right? And the item byte size, it will go into the scale. So I basically can just say that, so I think it's called SIB scale or something. What's the name of it? SIB scale, yes. SIB scale is SIB scale 1, and then I can do switch of, or if item byte size is 2, then scale is SIB scale 2. It's not very exciting code, but that's just how it is. C is not very good at expressing these kind of things. So 8 and 4, right? So that seems fine to me. Okay, and then we can take this scale and we put it here, and I will just reorder these two fields, because now if you look at the first initials, you'll see that SIB again stands for scaled index and base, I think. Is it right? Index byte. Okay. This is very interesting that this is scaled index byte, but this is scaled index base. Whatever. Doesn't matter. Okay. This looks fine, and we can try to run the tests. First of all, I want to make sure that I will actually disable this branch for now. Maybe I'll just put false here. with something very visible and say false end, because I want to force myself into doing this. And so when I run the tests, the encoder is probably going to complain if I done everything right, that they has no idea what to do with this stuff. Okay, apparently I need to have some other problems fixed first. Okay, so it's not called reg, it's called reg. Yeah, that's because it should be brand and then reg. Okay. Conditional expression is you're not being very helpful. Whatever, I will do the original thing that I was going to do and comment this out. It's fine. Differs in levels of interaction. Like this. Okay. And actually here's our extra problem here, where we need to say register reg and put it over here, because we might end up with other operand in already in register A. The whole situation right now is temporary registers is not very robust in general, but we can survive it for now. The only thing we need to do is we need to figure out which register is actually okay to use, and this is why I had this page open. So right now we are using arrayx as a temporary register, and these are the registers for the parameters, so for arguments, so we better not touch them unless we want to also move parameters on the stack, which might or might not be a good idea. Let's see. And the point is, rex is definitely considered volatile, so we can do whatever we want with it. And also R10 and R11 are volatile. So these are the ones that we can actually use for our stuff and be okay with it. They have a bit of additional complexity associated with them because they are more than, they are these extra registers coming from 64-bit CPUs. And that means that they have this first bit set, which means that CByte is actually also going to be inside of a rex part of the instruction, but I guess we can figure it out. So all of these to say that here I need to say register R10. Okay. So that builds. Let's try to run this and see it fail gloriously. So it wants to move an immediate 8, which is 30 in hex, into M8. And it doesn't know how to do that, which is very understandable because our encoding stuff is not ready for these things. So encoding C. First of all, we need to add this stuff here. So there is this memory indirect, and we are saying that it's okay to have it when we have memory operand, and we also need to say that it's okay to have when you have register memory. So operand type SIB, and encoding is memory. And we can also say that SIB is okay if you have register memory. Yeah, something like that. So like this, it will actually, I think, find the encoding, but the result is going to be completely wrong. So it will probably crash at runtime, I think. No, luckily I had even more protection for myself, which is great. Yeah, okay. It crashes here because, as I said, we had to do it for the stack pointer, but proper support SIB for non-respirators. See, sometimes you come back to fix me's and actually fix them, or hopefully fix them. So here's what we need to do here. We need to say if operand type is operand type memory indirect and operand indirect reg is RSP reg. Actually, like this. Needs to be nested thing. So for register, for RSP, we are doing something very specific. We need to say this encoding stack operand, and we say it needs SIB, and we do this CByte. I will for now leave it as a custom thing. Okay. And this is technically not correct. So I also want to change this part. So if we look over here, yeah, so we are using, as you can see, SIB and register SP share the same bit pattern. So I want to be more explicit and say actually it's RM SIB that is we are dealing with, not the not whatever was in the register. So RM is RM SIB. And otherwise, we can just take RM and put this stuff there. So this makes sense. Else, if operand type is operand type SIB, and else assert unsupported operand type. Yep, something like that. We don't need these. And now the big question, what do we put into here? Well, first of all, we definitely need these needs SIB, because I think what it does, yeah, so it just appends the actual byte, right? This is all that it's doing, I think. I guess so. There is also need SIB, initialized to false. Okay, cool. So that makes sense. We do need to say that we need SIB. Another thing is we need to do this stuff. And we need to check which bit actually goes into the rex byte when we have registers. It's again like these from RA to R15. And I will need to get the Intel manual, because the other web page, even though I like it, it actually doesn't have the right thing. CBytes, table 2.1. This is a bit of a nightmare to decipher, but let's look at this. So this actually doesn't speak about the rex. And this is not what I want. I want to know where in here goes the rex part. So let me go back to this stuff and rex prefixes. Yes, this is what I want to know. So there is this SIB no, this rex prefix. And for this is an extension of SIB index field. Okay, so I actually need to look at that, and this is exactly where we are storing R10. Okay, so if operand SIB SIB, yeah, index, then I need to do rex x, I guess. Do I even have rex x? Okay, I do. Good. So this seems fine. Yeah, so we still need to... this is actually also broken a bit, I think, because it does not... extension of mod rm field, CBase field, or opcode field. So going register memory. So we have where register memory indirect, extension of rm field, CBase field, or opcode reg field. So I believe this check needs to be here as well as an X check. Same as here. So I'll say to do check if we need to add rex here too. Rex x here. Well, that's not important for now because we will not get into this case, I think. Okay. Now let's start putting things in. Probably will want to create a helper function for CByte as well, but that's for now. I prefer to do it manually. So SIB scale, okay. This needs to come out of operand SIB scale. Then we have next one is index, I believe. So operand SIB index. And I'm not sure it's particularly important, but I want to mask all of these fields to make sure that they are the right size. I don't need to do it above in the stack case because they're basically static and I know that they are correct. But here, I think it makes sense to actually mask these things, especially because the register fields can be, again, 4-bit wide instead of 3-bit wide, which would make them which will produce wrong result if you just store them. So I guess this is what is supposed to happen. And maybe for consistency, I actually want to do this. Okay, so we have scale, index, and base. And again, this can be verified in here. Somewhere. Anyhow, this is also here. Yeah, scale, index, and base. And if we put everything correctly, then it should be fine. Displacement, also something that needs to be fixed at some point. So we should use a smaller displacement if we can. For the register, it is for the stack, it is easier to always use 32-bit because otherwise you end up with interesting calculations, but it's fine. Well, let's try to run this. This is gonna be quite interesting. Something did not work. So I guess my encoding is not the right one. Okay, so let's get back to maybe not these, but these things. And I will need to have this instruction. So this will be like move. And then what is the... So like, I don't know. 0 plus, or I need to say like cc plus rsp plus r10 times 1, and I would just say like 30. Junk 30 after expression. So compiler explorer will help us to tell what is the right disassembly for this. I think if I do something like int star make array, whatever, and it will accept int size, I would say int star result is malloc of size for int e0 I is less than size plus plus I, and result I is I. So you don't know what malloc is. Is it like string.h or something? Std.lib maybe? I never remember where malloc is. C malloc, which library? System library, blah 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 blah. Yeah, whatever. It says it's std.lib. So what's your problem? Oh, you can't convert because it's C++. What's your problem now? I think your problem is you're very slow. So let's switch to this version. Okay, and I'm interested in /ox. And somewhere in here, yikes. It unfortunately made it vectorized. That's not very cool. Well, so this seems fine. Keyword Peter. I need to say something like byte putter. Let's put R10, RSP, R10, and I will remove these things for now. I'm missing a comma maybe. R10 is not allowed with move B. Can I put back this stuff? Okay, so that's good. I'm not really good with the syntax of assembly. I understand the bytecode, but like instructions, but I don't understand the syntax always. Maybe I should learn it better. The reason I'm trying to do this because we'll need to look at some disassembly, and I'm trying to understand what should be the correct encoding for something like what we are trying to do. So this is gonna be this rex x for the RSP. This is this 42. Then C6 is a move. 84 is mod byte. This is CByte. This is displacement. Actually, this whole thing is displacement. And then this is the value. This is what we are trying to achieve. Now let's open the debugger. We'll need to break in the right place, go into disassembly and see what is going on. So we need to go here, and this is the right thing. So I think I should extract it now. Checker is this stuff, just so it's easier to step into the disassembly of this. Checker. Okay, let's rebuild. And let's run. And now we can go to disassembly and we can step into this function and see what's going on. So this looks fine, and this is a problem. I think this is where it crashes. So what's going on over here? It looks like I actually messed up. I wonder if so it's very sad that I don't know which line this particular instruction is associated with. Okay. So something is definitely not right at all in all of this. So everything after this XOR is really messed up. I think all of this jazz is wrong. What is the original code that I'm even trying to do? Function, fizzbuzz, right? So this is just a static, so it's not even visible in the assembly output. We set 0 into the R10. Okay, that makes sense. And if we look at R10, where are you? Well, it was 0 before, so nothing really changed, but that's good. And now let's compare this thing, I'll have to open the Bright website again. So where are we going wrong? 42 is correct. C6 is fine. Even 14 is fine. But it looks like mod RRM is wrong. And that is because I didn't actually set it to the right thing. So of course it's wrong. Here we need to say RM is SIB. And let's see if that will help the situation. So I've built, let's run disassembly inside. Okay, it helped somewhat the situation. We are putting the right things, sort of. So this is 1 and 2. Okay. So, oh, I think I know what's going on. Here, needs mod RAM. Do I actually set it? Okay, this is set all the way over here, so that's good. It means we are going into this branch. And yeah, so here I need to say, or am I putting this stuff? So indirect displacement is used all over, but indirect is actually not used. So here it needs to be like this. We need to also do this in this case. And then displacement needs to be like operand type indirect, then you get it from indirect, and then otherwise you say operand SIB displacement. Operand, no, operand. Okay. So hopefully we'll now go into this branch and we'll code, because what's happening here, I already stopped it, okay, but basically we were missing this part, and means that the next instruction was being interpreted as part of the previous one. So let's build this. And let's go inside again. So here, and this is actually looking pretty promising. So we clearing this, we are putting 30 into the first byte, then we are putting the this is awkward. So this is also wrong. And the reason this is also wrong is because of the displacement and the way I chose to deal with this stuff. So yeah, negative displacement is used to encode local variables. How do I want to deal with that? This was a pretty clever solution at the point I did it, but now it comes to bite me. So the problem right now is, if you look at here, like this is our array. And here it is -40 and here is +40. So that's no good. And somebody at some point needs to deal with that. And I guess inside of the SIB, I will need to do that. So I'll need to say that if operand SIB base is RSP register, then do that. To do, reconsider how stack offsets are handled. Okay. So let's rebuild and see if that will help me in any case. Disassembly inside. I'm not certain that's a correct offset. Like it all. Actually, no, it is. It is. Yes, because here it is RSP plus 48 loading into RCX or something. RSP 38H. Move S6. Not sure what's happening over here. R8D, RL, R9. So this is, let me look at the call. So guess this, the handle at -18 is this stuff. So this is this call. The result of it is in Rex, and we're storing it in a stack. That's fine. Then we are loading the address of the array in Rex, I guess. We are putting it back on the stack, which is not very efficient, but that's fine. And then we are putting it into RDX. Okay, yeah, it actually should be correct. Well, let's try to step through this and see what's going on. I can actually try to say something like, how do I do this? I already forgot. Is it like that? Let me see. I already forgot how to say byte. Star. No, it's not byte. What? How's it called? I'm totally spacing on that. Can I use int 8? 8. Int 8t of 0. That's fine. No, you don't know what int 8 is either. Unsigned. No. Okay. So this is fine. And here I would say RSP plus 0x48. And we should write there 30. And we have there 30. Great. And you can see that now this should change to 1 and this should change to 2. 1, 2. Great. So it looks like this is working. Let's uncomment that loop and try to run just with the loop to make sure that the loop itself works. Looks like loop works, and this is our 0, 1, 2 that we are printing from here. And now we should be able to do a really scary option of I and plus I. So we should print 0, 1, 2, 9, and here I would say I. Well, that's a bit of a moment of truth for this, because if this code works, then the next logical step would be to implement conversion from integer to a string, but that would not be in this video. For now, I just want to make sure that all the parts that we will need work just fine. Okay. Assertion did not find an acceptable encoding. And this is coming from function C, line 142. Okay, we can go to line 142. So obviously it is a move instruction. And this should be changed now to, I wonder if it makes sense to merge indirect and SIB stuff and just say that if index is 0, then we have to have a special value in case it's not just 0, it's like invalid stuff. Don't know. For now, I would say that I will just add a helper. Operand is memory. And the same thing here. I might have to review more code for this change, but for now, let's just make this work. And here there's operand is, we actually have operand as memory. So that's good. I can add operand type SIB. So hopefully more places are already using this and we have it working fine. Let's try again. Well, it didn't crash and it actually resulted in a correct sequence of numbers. That's great. I'm pretty happy with that. There is definitely some topics to think about in the meantime about this whole stack encoding thing. I mean, if it works like that, that's, I guess it's okay. If you find that something is broken again, then it would be a separate topic. But now we can encode loops in the way that they were meant to be encoded in x86, where you have a separate index and separate base. Of course, right now we don't do any register allocation, which means that this is actually an on-stack variable, and this is not cool. But the whole register allocation is a very, very complicated topic, and I probably will first do some ad hoc stuff just to try out and to show maybe why you shouldn't be doing some ad hoc stuff and do something more traditional. But again, this is a separate and very big topic. For today, that will be it. If you made it this far, then thank you very much. I'm pretty happy with the result and looking forward to working on more things to make FizzBuzz a reality. Goodbye.